The 30 kilogram cart A is connected to a spring as shown in the figure. The spring is initially unstretched and the cart is released from rest. Determine immediately after release A, the velocity of the cart after it has moved 120 millimeters down the stretch, and B, the maximum distance D that the cart could possibly reach. So this is the situation. A cart is connected to a spring. The spring is initially unstretched. At t equal to 0, the cart is released. So it will fall down on the ramp. But because it is still attached to the spring will try to pull up back the cart, depending on the force created by the spring. So because of the friction on the floor with the wheel of the cart, there will be also friction force which is opposed to the action of displacement. So if the displacement is to the left downward, there will be friction force going up. So because of these two forces, after sometimes the cart will stop. That is question B. And the question A, we want to know what is the velocity when it has displaced by 120 millimeters. Let's say this is point 1 and this is point 2. And the displacement is positive downward to the left. All the forces that apply to A must be projected towards this direction to produce works. We are going to use kinetic work energy. So T1 plus the sum of all works equals T2. So let's find T1. T1 is the kinetic energy of the cart at 1. It is 0. You know that T1 is half mv squared. At position 1, it is 0 because the cart is released from rest. The velocity is 0. If the velocity is 0, the kinetic energy is 0 as well. At 2, we have a velocity v2, but we don't know the value. So we have the kinetic energy of the cart at 2, half mv2 squared, where m is 30 kilogram, v2 we don't know. So we have 15 v2 squared. So we have finished with T1, T2. Let's go to the sum of all U. We focus on the displacement from 1 to 2. So let's see the forces that applies to the body. First, we have the weight. And this is the displacement, the component of weight that is parallel to the displacement. That will be W sine 30 degrees. So the work due to the weight of cart A, you just multiply W sine 30 with the displacement 120 millimeter. Of course, you convert 120 millimeters to meter. mgd W sine 30 times D. mgd sine 30. If you put the value, so you have 17.66 joule. Joule or Newton meter, same thing. Now let's see the work from 1 to 2 due to the extension of the spring. The spring will extend. Because of the extension, the force will be directed upward, but displacement downward. So that will be the direction of spring. The force is opposite to the displacement. It means we are going to have a negative work. So putting the values, you have work due to the extension of the spring, negative 2.88 joule. Friction is there. I forgot to put, but in the problem, there is a friction coefficient of 0.2. To calculate the friction, you need to calculate the normal force perpendicular to the floor. The friction is directed upward. Friction is always opposed to the direction of motion. If the motion is downward, friction upward. And the friction depends on the normal. The normal, as a matter of fact, in this case, is equal to the weight component in the perpendicular direction to the floor. So W cos 30. I didn't draw completely every body diagram. The work produced by the friction force is negative because the direction of the force is opposite to the direction of displacement. friction force is mu times N. N is the normal force reaction from the floor. N is W cos 30. That is the N. If you see the direction perpendicular to the floor, we have only two forces. One is N, one is W cos 30. It is in equilibrium because the cart doesn't move in that direction. So that's why I put directly N equal to W cos 30. So you have negative 6.12 joule. Sum of all the works. Put the value. So you have 8.66 joule. That is the sum of all works. Now we put back to the work energy principle. We have this equation, T1 plus sum of all works equal to T2. T1, you know, it is 0. Sum of all works, you have 8.66 joule. And then T2, we didn't know. It is dependent on the velocity 2. So having this equation, you can solve V2, 0.76 meter per second. Second question. The maximum distance, D, that the cart could possibly reach. So now the scenario is that after B, it will still continue to go downward because at B still has velocity. You see the velocity is still positive. It means the motion is still going down. It means it will continue at a certain distance. It will stop because the force from the spring and the friction will counter the force from the weight in the parallel direction to the displacement. So let's do again. Maybe you can go directly to the equation, but here I show you step by step. Kinetic energy of the cart at 1, I return back to 1, is 0. Kinetic energy of the cart at 2, in this case, when it reached the maximum distance, it is 0 as well. It stopped there. I repeat, just like previously, the work from the cart due to the weight, still mgd sine 30 degrees, but now the d is unknown. And then from the spring, also the same equation, except now the x, which is the d, you don't know. And also from the friction, it's the same equation, minus mu and d, but we don't know the d. So you sum up the work. You are going to have this quadratic equation with variable d. Finally, you put all the equation obtained in the work energy equation. So you put one by one. So you are going to have a quadratic equation. This one you can factorize. You have two values. One is d equal to 0. One is d equal to 0.48 meter. This one is not the answer. Why? Because we want to obtain the maximum distance. D equal to 0, it means the spring doesn't stretch. So in this case, the maximum is 480 millimeters or 0.48 meters.